In this Blender video, I'm going to demonstrate how to make this visual effect of a meteorite crashing into the ground. We'll be combining this live action shot of a scene at the park with a computer-generated meteorite crashing into the ground. The result will look like this. For this video, I'll be using Blender version 2.93.5. Let's start by deleting the cube. Now we'll do some motion tracking using the video that I took at a park. Blender has a workspace that we can use for this. So click the plus tab and select VFX and then motion tracking. Next we'll click the open button and select the video. Now switch to the output tab and select the frame rate that was used for the video. In my case it's 30 frames per second. By default, the colors may not be quite right, so switch to the Render tab and in the Color Management section, change the View Transform to Standard. Next, we'll set the start and end frames of our animation to match the video. This can be done automatically by clicking the Set Scene Frames button. Our goal here for motion tracking is to have Blender's camera match the movements of the camera that I used to record the video in the park. The process that we'll use has two parts. First, we'll add markers to the video that Blender can use to track the motion. Then secondly, this marker information will be used to calculate the motion for Blender's camera. You can add markers manually or automatically. We'll add them automatically by clicking the Detect Features button. Next, we need to track the markers. Control-T is the shortcut for this, or you can click the Track Markers button. Since many of the markers go out of view during the video, we'll add more markers at frame 50 and then again at frame 70. So we'll move to frame 50 and click the Detect Features button and then click the Track Markers button. Now we'll move to frame 70, click the Detect Features button, and then click the Track Markers button. To hide any disabled tracks, open the Clip Display popover menu and disable Show Disabled. Next, we're going to identify any markers that did not track properly and delete them. We'll do this by using the graph at the bottom here. Each marker corresponds to a green track and a red track on the graph. The tracks with good tracking should be similar in shape, so we're going to look for and delete any of them that don't conform to the typical shapes. This is probably the most obvious track that's not right. Much of the time it can be pretty easy to spot the tracks that should be deleted. By the way, the red tracks correspond to the movements of the markers along the x-axis as the video is played. The green tracks correspond to the movement along the y-axis. There's just a few more that we're going to delete. Now we're going to get ready to have Blender use this marker information to calculate the motion for Blender's camera. The calculation will be more accurate if we tell Blender the focal length of the camera that was used to capture the video. So switch to the Track tab and open the Camera section and the Lens section. If you do an internet search to find out the focal length of your camera, keep in mind that many times manufacturers will report the equivalent focal length of your camera. This is done to make it easy to compare cameras. The basic idea is that the equivalent focal length of your camera is equal to the focal length of a 35mm film camera, which produces the same field of view. So for example, my camera is advertised with a focal length of 26mm, which means that it has the same field of view as a 35mm camera with a 26mm focal length. So I'll enter 26 here. Since 26mm focal length is referenced to a 35mm camera, I also need to make sure that the sensor width is set to 35. Now switch to the Solve tab and enable Refine Focal Length. This will allow Blender to refine the value during camera solving. Also enable keyframes so that these values can be determined automatically. Next, click the Solve Camera Motion button. Blender is now trying to determine the motion of my camera as I took the video. Blender's camera will then copy this movement. You'll notice here that it refined the focal length a little. The average solve error is displayed here. You can see the error for each individual track in the dope sheet. I like to keep the average solve error to less than 1, but I also don't want any individual error to be too large. This one is almost 2, and this one is more than 2. So I'm going to remove any track with an error greater than 1.5. To do that, come down to the cleanup section and set the error to 1.5. Then set the type to delete track. Now click the Clean Tracks button. If you look in the dope sheet, the tracks with errors larger than 1.5 have been removed. Now click the Solve Camera Motion button again. The status is displayed at the bottom. The average solve error is reduced a little. Next, click Set as Background button to add the video to the background in the 3D viewport. You can see that up here. Then click the Setup Tracking Scene button. This will add a plane and a cube to the scene. We want to move the plane so that it represents the position of the floor in the scene. To do that, we'll select 3 markers that are on the floor. Holding the Shift key while selecting the second and third markers will allow us to add them to the selection. Then click the Floor button. You can see the results up here. Sometimes when you do this, the plane will not be oriented properly. If this happens, select 3 different markers and click the Floor button again. In our case, Blender did a good job, and so I'm going to keep this. If I play the animation, you can see that the plane and cube look like they're on the ground. We're done with camera tracking now, so let's add a meteorite crashing into the ground. So switch to the Layout workspace. Press 0 on the number pad for camera view. Now press S and scale the plane up in size. Let's also scale it up even more on the y-axis. Next, we're going to add the meteorite using an add-on. To do that, from the Edit menu, select Preferences. Then switch to Add-ons. From the drop-down menu, select Add Mesh, and then enable Extra Objects. I'm going to select the 3D Cursor tool and move the cursor. I don't need the Cursor tool any longer, so I'll switch back to the Select tool. Now press Shift-A and select Mesh. The add-on that we enabled gives us a rock generator option, so we're going to select that. We can customize the rock by using the Last Operation panel. For the preset, select Asteroid. If we disable Use a Random Seed, we can look at some different asteroid shapes by changing the user seed. I'm going to use this one for our meteorite. Next, press S and scale the meteorite up in size by 2.5. Let's also change its name to Meteorite. Then switch to the Material tab and add a material to it. I'm going to make it a light gray color. Next, we're going to animate the movement of the meteorite from frame 1 to 60. We'll start by moving to frame 60. Then I'll press N to open the sidebar and use the location values to move the meteorite into position. I'll just alternate between the X and Y values to move it back. For the Z value, I want the meteorite to be a little below the surface of the ground. Now we'll set a keyframe by pressing I and selecting Location and Rotation. Next, move to frame 1. Now I'll press G and move the meteorite into view. We can use the Y location value to move the meteorite back into the distance. But you'll notice that once it reaches a certain distance, it starts to disappear. That's because the camera is clipping it. To fix this, select the camera. Then switch to the Object Data tab if it's not already selected, and change the clip end value to 500. Now when we select the meteorite and move it back on the y-axis, it doesn't disappear. Next, we'll use the location values to move the meteorite into its starting position. We're also going to make the meteorite rotate while it's falling, so we'll set the Y rotation value to 360. Now we'll set a keyframe by pressing I and selecting Location and Rotation. When I play the animation, we can see how the meteorite moves, and you'll notice that it slows down near the end. So let's give it a constant speed. To do that, switch to the animation workspace, and in the dope sheet area, press A to select all. Then right-click and select Interpolation Mode, and then Linear. Now we'll switch back to the Layout workspace, and when I play it, it moves at a constant speed. I don't need the sidebar right now, so I'll press N to close it. Next, we're going to set up a liquid simulation, which will use large clumps of dirt instead of a typical liquid. This is what our meteorite will crash into. I'll press 0 to exit camera view. We're going to need a cube, but for some reason, the cube that was created when we set up the motion tracking doesn't seem to work with a liquid simulation. So let's delete this cube and add a new one. Then press S and scale it up in size by 25. Now I'll press N to open the sidebar and set the Z scale to 1. Next, from the Object menu, select Quick Effects and then Quick Liquid. This creates a liquid domain which will contain our liquid simulation. I'm going to change its size. When I press 1 on the number pad for front view, you can see that our original cube is wider than the liquid domain. Normally the cube would be contained completely inside the liquid domain, but I don't want the liquid to move until the meteorite hits it. Using the setup that I'll show you accomplishes this. So press G and then Z to move the liquid domain straight up until the bottom of the liquid domain is even with the bottom of the cube. Now switch to the Physics tab and set the resolution divisions to 70. Then in the Cache section, set the type to all. The Format Volumes value defaults to OpenVDB. When I used this option, the clumps of dirt would rapidly change in size, creating a flickering effect. By changing this to Unicache, it's much better. A few clumps of dirt may suddenly change in size, but it happens so infrequently that it's not too noticeable. We're going to bake a quick simulation, but we don't need to bake all of the frames right now. So to speed things up, let's temporarily set the frame end value to 10. Now click the Bake All button. When it's done, move to frame 5. You can see that the bottom of the liquid domain is filled with particles. Next, switch to the Particles tab, click Liquid, and expand the Render section. Set the Render As value to Object. Now we need an object to render, so let's create a clump of dirt. So press Shift-A and add a Mesh Icosphere. Then in the last operation panel, set the subdivisions to 1 to simplify it a little. Now press G and move it below the floor to keep it out of sight. Next we'll change its shape. So tab into Edit mode and select the top half of the object. Then press S and scale it up in size a little. Then press G and move it up a little. Then press R and rotate it a little. Now tab back into Object mode. Now select the liquid domain and set the instance object to the icosphere that we just added. These are the icospheres. Next, enable object rotation so that the object's rotation will be used. Then change the scale to 2. By making them so large, they'll overlap, which can give the appearance of new shapes. Also change the scale randomness to 1 so that they will be multiple sizes. We don't want the liquid domain cube itself to be visible, so disable Show Emitter here and also down here. Next, we need both the liquid domain and the cube to be selected at the same time. The liquid domain is already selected, so hold down the Control key and click the cube to add it to the selection. Now press G, then Z, and move the liquid domain and cube down together until the icospheres are just below the floor. It's not easy to see here, but the floor is at the center. Next, we'll make the meteorite part of the liquid simulation, so select it and switch to the Physics tab. Then click the Fluid button and set the type to Effector. Now let's look at the scene from the top, so press 7 on the number pad. As I scrub the timeline, we can see the direction that the meteorite travels. This is its position when it's done moving. With the meteorite in this position, we can now set the position of the liquid domain and the cube. So select the liquid domain. Then hold down the Control key and select the cube to add it to the selection. Let's start by rotating them. I'm going to do this by pressing R, then Z, then 18, then Enter. Then press G and move them into the position that you want. Small changes can make a big difference, so if the final result doesn't turn out the way that you want, just come back here and move them into a different spot. I found that placing this edge close to the meteorite gives good results. Now that the liquid domain and cube are in position, let's resize the ground. So select it and tab into Edit mode. Then select the left side vertices and press G, then X, then drag until the ground is under the whole liquid domain. Then tab back into Object mode. Let's bake the simulation using all of the frames. So select the liquid domain, and then click the Free All button. Change the frame end value to the length of the video, which in my case is 159, and click the Bake All button. I'll pause the video while it's baking. It's done baking. Now I'll press 0 on the number pad for camera view, press N to close the sidebar, and then switch to solid view. Now I'll play the animation, and I'm speeding up the video for this part. This looks good. Next, we'll set up the light source, so select it and switch to the Object Data tab. Change the light source to Sun and set the strength to 3. Then press N to open the sidebar and set the Z rotation value. In my case, I'll use 80. Now press N to close the sidebar. Next, we'll set the material for the icosphere. So select it, switch to the Material tab, and add a new material. I'm going to set the base color to a hex value of 73562C to give it the color of dirt. Then set the roughness to 0.9. Now let's change the frame number to bring the icospheres into view, and then switch to the shading workspace. Now switch to rendered view. Select the render tab and set the render engine to cycles. To make the video of the park visible in the render, open the film section and enable transparent. Now we'll add some texture to the icospheres. So press Shift A and select Texture and then Noise Texture. Then Shift A, Vector, and Displacement. Connect the factor output to the height input and the displacement output to the displacement input. Now set the scale to 2 and the detail to 16. To get rid of some of the sharp corners, switch to the Modifier tab and add a bevel modifier. Set the number of segments to 2. Now switch back to the Layout workspace. We now have clumps of dirt flying up in the air when the meteorite strikes the ground. The next thing that we're going to do is to create a hole in the ground. We'll be using dynamic paint to accomplish this. We're actually going to be making 2 holes. We'll add a mesh plane the color of dirt, which will have the hole that we'll see, and we'll create another hole in the existing ground so that we can see the dirt-colored hole below it. So press 7 on the number pad for top view, and then switch to wireframe view. Now press Shift A and add a mesh plane. Press S and scale it up in size by 35. Press G and move it over the liquid domain. Then press N to open the sidebar and set the Z location to -0.02. This will put it just below the ground. In order to make a hole in this object, we need to give it more geometry. So tab into Edit mode and press A to select all. Then right-click, select Subdivide, and set the number of cuts to 100. Then tab back into Object mode. Now we'll set up Dynamic Paint. So switch to the Physics tab and click the Dynamic Paint button. Dynamic Paint uses canvases and brushes. The plane and the ground will be our canvases. The meteorite and the clumps of dirt in the liquid domain will be our brushes. So click Add Canvas and set the surface type to Displace. Set the Displace factor to 2. Next, select the ground and tab into Edit mode. We need to add more geometry to the ground in order to make a hole in it, but we don't need the entire ground to have a lot of geometry. We only need a lot of geometry where the hole will be. So we're going to subdivide in 2 steps. So press A to select all, right-click, select Subdivide, and set the number of cuts to 15. Then select the vertices in the area where the hole will be. Then subdivide again by another 15 cuts. Now tab back into Object mode. Next, click the Dynamic Paint button and then click Add Canvas. Set the surface type to Displace. For the other canvas, we set the Displace factor to 2. We want the hole in the ground to be larger, so set this Displace factor to 10. Now we'll set up the brushes. So select the liquid domain, click the Dynamic Paint button, change the type to Brush, and click Add Brush. For the paint value, select Particle System. For the particle system, select Liquid. Then set the Effect Solid Radius to 2. Now select the meteorite, click the Dynamic Paint button, change the type to Brush, and click Add Brush. Next, we'll make some adjustments to ensure that the dirt-colored hole can be seen through the hole in the ground. So press 0 on the number pad for camera view and switch to solid view. Then select the ground, switch to the Material tab and add a material. Open the Viewport Display section and set the color to green. This green color will not be in the final render, it's only used in the viewport display. This green color will help us to distinguish the hole in the ground from the dirt-colored hole. I don't need the sidebar, so I'll press N to close it. Now I'll play some of what we have so far. I'll speed up the video for this. If either of the holes are in the up direction instead of the down direction, then change the displace factor that we previously set to a negative value. Here you'll notice that some of the green on the ground is covering the hole beneath it. To fix this, switch to the Modifier tab and add a Smooth modifier. Set the repeat value to 20. Now it looks much better. In the final render, you'll notice that the sides of the hole are a darker color than at the surface. I'll show you how to do this. So select the plane and switch to the Shading workspace. Switch to Rendered View if it's not selected already. Now switch to the Material tab, add a new material and select the brown material. Then click the New Material button to make it a copy. Now press Shift-A and select Input and then Geometry. Then press Shift-A and select Converter and then Separate XYZ. Connect the position output to the vector input. Then press Shift-A and select Converter and then Math. Set the math type to greater than. Connect the Z output to the value input. Then press Shift-A and select Color and then Mix RGB. Connect the value output to the factor input. Now set both color 1 and 2 to the same color as the base color. Then make color 1 a little darker. Now connect the color output to the base color input. These two nodes allow us to find the position of the hole on the z-axis. If the z position is greater than the threshold, the lighter color will be used. Otherwise, the darker color will be used. In order to set the threshold, let's look at the z location of the plane. So press N to open the sidebar. The z location is minus 0.02, so we'll set the threshold to a slightly lower value. I'll use minus 0.03. Now the sides of the hole are darker than the top, but I think I made them too dark, so I'll lighten them up a little. This looks better. I'll close the sidebar so that we can get a better look. Now switch back to the Layout workspace and switch to Rendered View. Before rendering the final animation, switch to the Render tab and disable Motion Blur. The animation is ready to render now. I rendered this using 32 render samples. For those that may not know how to render an animation, I'll put a link to a video for that in the video description. Well, that concludes this video. Thanks for watching, and please subscribe and leave a comment.